One of the first things we need to talk about is all of our transformations with an absolute value. Okay? And being that it's an absolute value and you can't distribute in and out of an absolute value, I can give you a blueprint of all the transformations. So H would be in the absolute value, so that would be your left and right movement. And adding, you're going to the left. Subtraction, you're going to the right. And then outside the absolute value, if you're adding, subtracting, adding would be up and subtraction would go down. Right? That correlates to your H and K on your transformations over there. So if you're inside, it's left and right. If you're outside, you're up and down. Okay? Multiplying, if you're multiplying on the outside, that would be a vertical stretch or compression. And how do you know if it's a stretch or compression? If it's bigger than 1, it's a stretch. You stretch by 2, you stretch by 3, you stretch by 5/4. If it's less than 1, you compress. So you do compressions of 1/2, compressions of 1/5, and so on. The other one would be if you're multiplying inside the absolute values. All right. So if I had, well, let's do negatives instead. Let's move to negatives. If I have a negative outside here, that would be reflect over the x-axis. If I have a negative inside here, that's reflect over the y-axis. Okay. So what we're doing today is we're going to describe the transformations, and then we're going to graph, but we're going to graph using our graphing calculator. So that's going to help us in 2 ways. It's going to get us points to graph, and our absolute value function picture on our graph should match the transformations that we said. Okay. All right, so let's try the first one. So I have the absolute value of x minus 2. Okay, so if I'm subtracting outside the absolute value, what kind of transformation is that? What would minus 2 outside the absolute value be? Down 2. It's going to match the k, right? So that would be down 2. So I know, what I know is that my parent function looks like this. My parent function of absolute value. So if I'm going to take this absolute value and go down 2, my vertex now from 0, 0 is going to be negative 2, 0. Right? So I know just by looking how I move left and right, up and down, where my vertex is going to be. But then to find points to graph, right, let's get our calculator, turn it on, and go to your y equals, clear anything out that's in there, because other students have been using those calculators. And to put in absolute value, you go math over to num, and then enter on abs. And then put in your x, the absolute value of x, close your parenthesis, because that's the only what you're taking absolute value of, and then subtract 2, and then graph, and you should see that it moved 2 units down from my parent function. Then I can go second graph, and it'll give me points. And I want to scroll up and down on the x's until I get symmetry. So I would start at x is negative 3, because see how I have 2 1s, 2 0s, 2 negative 1s. I have symmetry on the y's. That means I have both sides of that absolute value. So you always want to scroll up and down on your x's so you have repeated y values. Right? So I'd fill in that in my table, negative 3, 1, negative 2, 0. And then I graph those points. Negative 2, 0, negative 1, negative 1. So my graph should look something like this. Okay, you don't have to have the black one on there, the parent function. I just wanted to show you that it moved 2 units down. Okay. Let's try another one. What transformation would this one be when I am adding 2 inside the absolute value? What's that going to be? That would be left 2. When I'm adding, subtracting, right, inside the absolute value, that's going to be my left. Okay. So what I know is that my vertex was 0, 0, and if I go left 2, I know my vertex is going to be over here now. Okay, that's what I know. But I need a table of values so I can graph this. So I'd go back to my calculator. Go back to y equals, and now I want the absolute value of x plus 2. Right, absolute value of x plus 2, graph it, and that it looks 2 units left, so I know my description's correct, left 2 units. Second graph, if I went left 2, my points are going to center around the negative 2. X is negative 2. That's where I'm going to find my symmetry. 2 3s, 2 2s, 2 1s. So good points would be negative 5, 3, negative 4, 2, negative 3, 1. Right? Those would be good points to pick off my graphing calculator and then graph those. This example, I have both movements. So I'm looking and I'm thinking, okay, I'm adding 1 inside the absolute value. So what does adding 1 inside mean? Left 1. And if I'm subtracting outside the absolute value, what does that mean? Down 3. Very good. So what I know about my vertex is that if I'm at 0, 0, and I went left 1, down 3, I know my vertex is here. Right, at negative 1, negative 3. So let's find some more points to graph. So y equals, and I want the absolute value of x plus 1, and then minus 3. Graph, and I can see left 2, down 3, so I know my description's correct. Second graph, and since I went left 1, I'm probably going to have symmetry around the negative 1 there. So that would be good points, negative 4, 0. Right? Because I found repeated y values. I have 2 zeros, 2 negative 1s, 2 negative 2s. That means I have both sides, so I'm good. So negative 4, 0, negative 3, negative 1. So let's look at some stretches. Stretches and compressions will take your absolute value and make it skinnier or fatter. It's going to stretch it or compress it. Okay. So let's just, I know this is probably too many examples, so let's just describe. What would this 5 represent? If I'm multiplying outside the absolute value, right, outside the absolute value, that's going to be a vertical stretch or compression, and since it's bigger than 1, it's going to be a vertical stretch of 5. Okay. Another example of that would be this one. This is actually 2 things. You can never do a compression of a negative number. Negatives always mean reflection. So this one's actually 2. This would be reflect over the y-axis. And this would be a vertical compression of 1/3. So 2 things there. Reflect over the y and compression. Negatives always mean reflection. So this one, the 3 would be what? What would that 3 be? A vertical stretch of 3, because it's bigger than 1. Okay? So let's graph some of those. So go down to the next row. So what two transformations, right? First of all, what two transformations? What does the 2 mean and what does the +1 mean? Very good. Vertical stretch of 2 and left 1. Because it's inside. When I'm adding inside, that's left and right. Okay? So I know if I go left 1, I'm over here somewhere, my vertex. Okay? So let's find some more points. Pull out my graphing calculator. Go to y equals. And I want 2 first, then absolute value. 2 times absolute value of x plus 1. Okay, like that. You can have 2 times absolute value, but if you just go 2 abs, that is telling your calculator to multiply. So you don't have to have that multiplication sign in there. And if I graph it, you should see it moved left 1 and got skinnier. That would have been the stretch. It got skinnier. So then second graph, I need to find symmetry. And that looks like good symmetry because I have 2 6s, 2 4s, 2 2s. So those would be good points in my table. And then graph those. 0, 2. Okay. And if you're noticing, some of you that higher level thinking, what you're noticing is your slope of 1 over 1 became 2 over 1 because I did a stretch of 2. So usually my absolute value function starts at the origin and goes up 1 over 1. But the stretch of 2 would make it up 2 over 1. So if you have your vertex here, basically what you're doing is going up 2 over 1 on both sides. That's what a stretch is going to do. Okay, it's going to stretch up that slope of 1. Oh, let's try another one here. How about this one? This one has a lot going on. There's 3 things going on with this one. What are they? Very good. Reflect over the x. This would be a vertical compression because it's less than 1. And then down 2. Very good. Okay. So it's going to reflect over the x-axis means now it's going to open down. A compression of 1/2 means it's going to flatten, right? So instead of a slope of 1, it's going to be up 1 over 2. It'll flatten out. And then it's going to shift down 2. So let's look at that in our graphing calculator. Y equals, I would go negative, right? There's a difference between your negative sign and subtraction sign. You want to use your negative sign here. And then parenthesis 1 divided by 2. Absolute value, so math, num, abs of x. And then minus 2. Graph. So you should see it moved, it reflected, it's opening down. It's fatter because it got squashed, it got compressed, so it's wider, okay? And then I can find some good points to graph. Second graph, I'd want to center around, 0. I probably wouldn't use the 0.5 points. I would scroll up and down and find like -6, -5, -4, -4. I'm just going to pull out the nice even points there. The nice integer numbers. So I don't want to graph decimals. And then I'd get way too many points close together. They'll be all kind of squished together. 6, -5, 4, -4. There we go. So -6, -5. I need to scroll down. So -6, -5, -4, -4. Okay. You should see the symmetry. And it got whiter.